Okay, let's review the material for the Module 4 quiz. We have balancing chemical reactions, types of reactions, classification of matter, physical versus chemical properties, gases, and just one question about acids and bases. Let's begin. Describe, balance, and type these reactions. Here we have hydrogen plus oxygen making water, so I would say this is the synthesis of water by combining molecular hydrogen and oxygen 2 to 1 to 2. AlCl3 is converted to Al plus Cl2. This looks to me like a decomposition of aluminum chloride to make aluminum and chlorine. Balancing, I think we're going to need 2 aluminums because the common multiple for chlorine is 6. So 2 AlCl3s form 2 aluminums. That balances the aluminum plus 3 chlorines. That is a decomposition reaction. NaBr plus F2 forms NaF and Br2. See if you can figure that one out. To describe it, I would say sodium bromide combines with fluorine in a single replacement reaction. Ab plus C forms AC plus B. So sodium bromide plus molecular fluorine forms sodium fluoride plus molecular bromine. And balancing it out, we better double the fluorines and the bromines. So 2 to 1 to 2 to 1. Type of reaction, single replacement. Next one, give it a try. Pause it if you really want to do these. It says Li2O plus AlF3, arrow LiF plus Al2O3. I would describe this by saying lithium oxide combines with aluminum fluoride in a double replacement reaction. So it's not really combines with, replaces with, to form lithium fluoride plus aluminum oxide. Type of reaction, double replacement. Balancing it out does not look that easy because we got 3 F's, 2 Li's, 3 O's. So let me see if I can try it just without writing things down. Let's see if you follow the logic. Lithium doesn't look good, so we need a 2 in front of it to balance lithium. That gives 2 on each side. Well, maybe I better fix the fluorine there. So that's 2 fluorines there, 3 there. So I'm going to have 2 aluminums there to give me the 6 fluorides. Would it? Let's just see what it came up with. There it is, 3 to 2 to 6 to 1. How about if I do this? Check that this is balanced. Lithium, 6 and 6. Oxygen, 3 and 3. Aluminum, 2 and 2. Fluorine, 6 and 6. Just go through each one, correcting as you go until they're all balanced here. Nothing shows up twice, so it doesn't matter what order you do it in. Type of reaction, double replacement. Last one, CH4 plus O2, arrow CO2 plus H2O. I'd really describe this as a combustion reaction. Yeah, that's what it is. Looks to me like it's burning. So I would say methane plus oxygen is combusted to produce carbon dioxide and water. Balancing it, C looks fine. H needs a 2 there, giving us 2 oxygens. I like that, right? But there's also 2 there, so I think that would give us 4 oxygens on the product side. So I'm going to say 1 to 2 to 1 to 2. That looks good to me. Methane burns, better word is combustion, forming carbon dioxide and water. And there you go. Classification of matter. Describe each as an element, compound, or mixture. How about if we solve it as we go? Brass is a mixture of, I don't know, copper and zinc, something like that. Copper is, and I hope you're answering these as I go, and then confirming with my answers. Copper is an element, Cu. Steel is a mixture of, I don't know, iron and carbon and other stuff. Blood is clearly a mixture. Wood is actually a mixture. It's primarily cellulose, so probably carbon, hydrogen, oxygen. Really, it's a mixture of cellulose and other substances, like water, for example. Air is a mixture of nitrogen, oxygen, and some other very minor components. Water is a molecule. It does have hydrogen and oxygen, but they're bonded together to form a substance known as water. Energy is none of the above. Trick question. It is not a form of matter. Milk is a mixture. Arsenic, surprisingly, is an element, AS. Aspirin is a compound, single substance. Uranium is an element, U. Saturn is an entire planet, so I'm going to go with mixture. Donald Trump, I will avoid any political comments, is a mixture. Sodium chloride is a compound of sodium chloride. Sodium and chlorine bonded together in a crystalline lattice. Okay, which of the above listed is liquid at room temperature and atmospheric pressure? This is just kind of a common sense question. I'm going to go with, let's see, brass, no. Copper, no. Steel, no. Blood, yes. Wood, no. Air, no. Water, yes. Energy, no. Milk, yes. Arsenic, no. Aspirin, no. Uranium, no. Saturn, no. Donald Trump, no. Sodium chloride, and so it's just a few there. And, ooh, this one's already answered for you. Which of the substances above are homogeneous mixtures? Brass is a homogeneous mixture. Look, that means it looks like one thing, but it contains more than one. Brass, steel, blood, air, and milk, I believe, all follow those sorts of rules. If you had something that was speckled like granite, for example, where you can clearly see more than one thing, those are called heterogeneous mixtures. Physical versus chemical properties describe each of the processes above as below, or here, as physical or chemical. Water freezing, I would say that is just physical. It's still water. Plant molding, yes, new substances are formed. See how I'm checking for that? Sanding, no new substances are formed. You're just grinding it up. Metal rusting, yup, new substance would be, for example, iron oxide. Breathing air, respiration is a chemical process. We're releasing CO2, for example. Taking a pill. Now, just the act of like physically placing it on your tongue before anything else happens, sure, that's physical. But once you take it, that thing is metabolized, etc. There's a lot of chemical processes going on, chemical. Parachuting, ignoring the sweat and fear that might go with it, I would say it's just gravity, therefore a physical process. List 4 aspects of the kinetic molecular theory. 1. Gas molecules are always moving. 2. When they bump into each other, they don't slow down. 3. They go faster when you heat them up. And I don't remember number 4. Oh, there's a lot of space between them. Absolutely. It's mostly just empty space between those molecules. Good. All right, now some gas law problems. Determine the final pressure of a gas given 1 liter, 2 atmospheres, and 25 degrees going up to 2 liters, doubling the pressure, and 50 degrees. Looks like it's doubling the temperature, but you're not. Don't forget you got to use Kelvin. If you place letters in front of these, you probably should. I'd call that V1, P1, T1. I'd call this V2, T2, and we're solving for the final pressure. That's P2. Anytime you have 5 of the 6, that's the combined formula. P1, V1 over T1 equals P2, V2 over T2. Plugging in and switching to Kelvin, which you must always for temperature by adding 273 to your Celsius, gives the following data. Solving shows that we have a final pressure of 1.08 atmospheres. Next one. Determine the temperature in a 2-liter balloon that has 4 grams of helium at your birthday at 1.5 atmospheres of pressure. We got a V. We got a T. Ooh, what is that? 4 grams of helium. Hiding within that is an N, the number of moles, and it happens to be exactly 1 mole. Look up helium on a periodic table. You'll see that the average atomic mass is 4 grams, so that's entirely 1 mole. And you're at 1.5 atmospheres of pressure. When you have V's, N's, and P's, you can solve for T using the ideal gas law, PV equals nRT. Don't forget R is just a number. Here it is plugged in, and solve the final, not final because nothing's changing. The temperature is 37 Kelvin. No need to change to another temperature because they didn't ask you to. Now you take that balloon, you stick it 10 meters underwater, and at that point the pressure on the balloon from the outside would double. What's the new volume of the balloon? Well, maybe you can do it by common sense. That's how I did it. If you're subjecting it to double the pressure, it will be half the volume. This is known as Boyle's law. You could also do P1V1 equals P2V2, but I'm just going to say it's going to get cut in half down to 1 liter. It would be half the size when you stick it down at the bottom of a deep pool. Finally, acids and bases, the only question we're going to ask is predict the products of the reaction of HCl with NaOH, and that should form acid plus base, hydrochloric acid plus a hydroxide, which means a base, will always form a salt and water when they're of the nice, simple, Arrhenius variety, as these are. And so HCl plus NaOH forms H2O plus NaCl. I intentionally only put one question for the acids and bases. However, if you wanted to, you could do a more complete review of acids and bases by going to some previous slides. Okay, good luck on your Module 4 quiz.